Welcome, brothers, to this explainer. Today, we're focusing strictly on a seriously critical standard operating procedure for your facilities, Troubleshooting Incident 17. Look, as plant operators and managers, you know exactly what I'm talking about. High total phosphorus in your effluent, it is definitely not just a minor hiccup, it's a massive compliance risk. So, in this explainer, I'm going to walk you through the exact step-by-step process to diagnose and resolve these high phosphorus spikes so you can confidently restore stability to your biological and chemical systems. Okay, let's just jump right into this logical, chronological SOP. We'll kick things off with a quick technology refresher, look at the physical and chemical symptoms, break down our root cause diagnostics, roll out a phased action plan, and finally, wrap it all up with essential monitoring.
All right, Part 1, Technology and Incident Overview. First things first, brothers. Before we can fix a broken system, we've got to ground ourselves in the actual science of how these systems remove phosphorus in the first place.
Now, your absolute primary weapon against phosphorus is EBPR, or Enhanced Biological Phosphorus Removal. This entire technology hinges completely on the life cycle of your PAO bacteria, that's polyphosphate accumulating organisms. These microscopic little workers literally do the heavy lifting for you, sometimes with a little backup from chemical coagulation. Protecting their very specific environment, that's your #1 priority on the floor. Bottom line, if the PAOs are happy, your effluent is clean.
Think of it like a two-step dance. During the anaerobic cycle, your PAOs are actually deeply stressed. They release phosphorus into the water while frantically absorbing volatile fatty acids, VFAs, and packing them away as energy reserves called PHB. Then they shift into the aerobic cycle. Here, they burn that stored energy to survive, and in the process, they uptake massive amounts of phosphorus from the water, way more than they released in the first place. We call this luxury uptake, and it's exactly what cleans your wastewater.
But here's the catch. They are picky. Maintaining the exact conditions these bacteria need is absolutely crucial. Your dissolved oxygen, or DO, in the anaerobic zone absolutely must stay below 0.2 milligrams per liter. It has to be truly anaerobic. You also need a sufficient VFA carbon food source. Your sludge retention time, your SRT, needs to be tightly maintained right between 10 and 20 days. And hey, if you're using chemical coagulation, your pH needs to sit comfortably between 6.5 and 7.5. If any of these parameters drift, well, your PAOs basically go on strike and they lose their efficiency.
And that, unfortunately, brings us to Incident 17. This happens when your effluent total phosphorus, or TP, blows past permitted limits. Typically, we're talking anything over 0.5 to 1.0 milligrams per liter. When you hit those numbers, you're not just risking immediate massive fines for the plant. You're risking severe ecological damage to the receiving waters. Think toxic algal blooms and total oxygen depletion. It is a nightmare scenario.
Okay, Part 2, Symptoms of the problem. So what are you actually going to see out on the plant floor when this biological engine starts stalling out?
The signs are actually really obvious once you know what to look for. Visually, you might walk by the clarifiers and see cloudy effluent, telling you you've got poor coagulation. Or maybe there's this weird white scum suddenly floating on the surface. Worse, your sludge might turn dark brown or pitch black, kicking off foul odors that scream your anaerobic zone is failing. Chemically, a test of the aerobic tank will show a sudden, massive spike in dissolved phosphorus. Brothers, listen to me. If you see white scum, black sludge, or cloudy water, your luxury uptake is failing. You need to act immediately.
Moving on to Part 3, Root Cause Diagnostics. Once you spot the symptoms, you can't just guess at the fix, right? Let's walk through the exact diagnostic steps to pinpoint where the system is breaking down.
Treat this like a pilot's pre-flight checklist. You need to work through these 4 steps sequentially. First, sample your outfall for total phosphorus and orthophosphate just to confirm the breach. Second, test the dissolved phosphorus in both tanks. Look, if the phosphorus isn't high in the anaerobic tank, your PAOs aren't releasing it properly to begin with. Third, verify your anaerobic DO at multiple locations to make sure oxygen isn't leaking in. And finally, analyze that VFA to COD ratio to ensure your bugs actually have the carbon fuel they need.
What's wild here is how clearly these testing thresholds link directly to the root cause of the failure. For instance, if your DO is floating above 0.2 milligrams per liter, your strict anaerobic environment is totally busted. The PAOs will just breathe oxygen instead of absorbing VFAs. And if your input VFA drops below 15 to 20 milligrams per liter, your bacteria are quite literally starving for easily degradable carbon.
But wait, there's more. You absolutely must check your sludge retention time, toxins, and pH too. If your SRT stretches out beyond 20 days, you are practically inviting competing bacteria, we call them GAOs, to crash the party. They'll eat up all that precious VFA carbon without actually removing a single drop of phosphorus. On the flip side, an SRT under 8 days, you're washing your POWs down the drain before they can even reproduce. Also, heavy metal toxins can completely paralyze the biology, and if your pH strays outside that 6.5 to 7.5 pocket, any chemical coagulation you try is going to be totally wrecked.
All right, part 4, phased troubleshooting action plan. We've got our diagnosis, brothers. Now, let's roll up our sleeves. We're breaking this down into an emergency response, short-term stabilization, and long-term prevention.
Okay, the clock is ticking. In the first 24 hours, your emergency priority is stopping the bleeding, hitting those discharge limits so you don't get fined. Boom! Immediately increase your coagulants, your ferric chloride, alum, or PAC. At the exact same time, get out there and adjust your return sludge valves to stop any rogue oxygen or nitrates from bleeding back into the anaerobic zone. If your SRT is creeping up, increase your sludge wasting to flush out those competing bugs. And hey, if a toxic shock is the culprit, immediately route your flow to dilute that incoming wastewater. Once the immediate panic is over, days 1 through 7 are all about stabilization. Go inspect those basins and patch up any air leaks destroying your anaerobic zone. If your influent is starved of carbon, start supplementing with external VFAs, like acetic or propionic acid. You'll want to dial your SRT tightly back into that 10 to 15 day sweet spot so the PAOs can recover and flourish. And don't forget to run daily jar tests to perfectly calibrate your chemical dosing. No need to burn money on wasted coagulants.
Now, to make sure Incident 17 never haunts you again, you've got to think long-term. Get management to invest in continuous DO and ORP meters for those anaerobic tanks. You need early warning alerts. Get in there and fix internal baffles so the water isn't just short-circuiting right past your bacteria. If you can, use an equalization tank to prevent flow surges from washing out your biology. And honestly, most importantly, train your team. Make sure every single operator understands the EBPR cycle so they can catch this stuff before it becomes a full-blown emergency.
Finally, part 5, monitoring and final summary. Because let's be real, corrective actions don't mean a thing if you don't verify they actually worked. Here is your daily checklist. You need to log these values religiously. Success is strictly defined as 3 to 7 consecutive days of stable total phosphorus well below the limits. You've got to verify the DO is staying below 0.2, the VFA is holding above 15 milligrams per liter, and that the phosphorus levels in your sludge are visibly rebounding. That's the proof that your luxury uptake is back online and working. Ultimately, brothers, the health of your entire plant boils down to one simple biological truth. If you protect that strict anaerobic environment and feed your PAOs enough VFA, they are going to do the heavy lifting for you. Everything else is just supporting that one core mission. So the question is, are you ready to step up and implement this rigorous standard operating procedure on your very next shift? Thank you so much for joining me for this explainer, and stay safe out there on the floor.